Small intestine is a long, narrow, folded or coiled tube extending from the stomach to the large intestine. It is a region where most digestion and absorption of food takes place. It is about 6.7 to 7.6 centimeters long, highly convoluted, and contained in the central and lower abdominal cavity. It is about 5 times longer than the large intestine, but has a smaller diameter. That is, the diameter of small intestine is about 2.5 centimeters, and that of large intestine is 7.6 centimeters. It is attached to the posterior wall of the abdomen by the mesentery. It is an extension of the peritoneum. It comprises the duodenum, is around 25 to 30 centimeters long, jejunum around 2.5 meters long, and ileum around 3.5 meters long. The entire convolution of the small intestine lies loosely in the abdominal cavity. It is loosely in the abdominal cavity, framed by the colon. Its force and the projections in its lining create an enormous surface area. These force and projections and the internal villi increases the surface area of approximately 200 meters squares. That is more than 100 times the surface area of the skin, which is essential for the absorption of nutrients. Then the acidic chyme from the stomach reaches duodenum. The duodenum completes a large process of chemical digestion, liberating small molecules from the ingested food. Duodenum consists of 4 regions. Superior region, an enlarged upper area of around 2 centimeters length, is also called duodenal bulb, which continues the pyloric sphincter. The pyloric sphincter separating the stomach from the duodenum, and is connected to the liver by the hepatoduodenal ligament. So this is connected to the liver by this hepatoduodenal ligament. Descending, this extends downwards into the abdominal cavity from the superior duodenal flexure. From this bend, it is extending into the abdominal cavity. Halfway down is the major duodenal papilla. This is the opening of the entry point of the common bile duct and pancreatic duct, which fuse before entering the duodenum. The entry of bile and pancreatic juice into the duodenum is regulated by a small ring of muscle. The sphincter of Oddi is at this opening. That is the major papilla. Then horizontal or transverse region. This is a horizontal or transverse region. The largest section of the duodenum, 10 to 12 centimeters long, and the main area of mineral absorption taking place here. Then ascending region, small area, slightly upwards into the abdominal cavity before connecting to the jejunum at the duodenojejunal flexure, this bending. The duodenum is primarily a region of chemical digestion. It receives secretions from the liver and pancreas, and its mucosa contains large numbers of mucus producing that is goblet cells and Brunner's glands, which secrete a watery fluid that is rich in mucus and bicarbonate ions. As in the stomach, mucus acts as a protective barrier against autodigestion, and it also lubricates the passage of chyme. The mucosal lining of the duodenum also contains tall columnar epithelial cells and extends into circular folds and finger-like projections. Here also you can see villi, but they are small and lesser in number. This increases the surface area of nutrient absorption. However, nutrient absorption is not the duodenum's specialty. It occurs mainly further down the small intestine in the jejunum and ileum. where the villi are longer, more numerous, and found at greater density. Jejunum. So, and the duodenal there are two papulas opening into the duodenum. Duodenal papilla, entry point of common bile duct, common bile duct and pancreatic duct. That is a greater papilla. Then, in some persons, there is an accessory pancreatic duct present in most individuals. It opens at the tip of the lesser papilla. So this ensures if in case there is any blockage in the common main duct, pancreatic duct, and this accessory duct will helps to pass the pancreatic juice into the duodenum. Jejunum makes up 2/5 of the total length of the small intestine, about 0.9 meters in length. Starts at the duodenojejunal flexure and ends at the ileum. There is no clear border between the jejunum and the ileum. It's a central section of the abdomen, comprises about 2/5 of the remaining tract. The color of the jejunum is deep red because of its extensive blood supply. Peristaltic movements are rapid and vigorous. And there is little fat in the mesentery that supports this region. Once digestion in the proximal part of the gastrointestinal tract is done, the jejunum and the ileum performs the role of absorbing these molecules, that is amino acids, monosaccharides and lipids into the bloodstream. Histologically, the jejunum differs from the rest of the small intestine by the absence of Brunner's glands, which are present in the duodenum, and Peyer's patches, which are present in the ileum. Mucosa contains large number of mucus-producing goblet cells. So they produce mucus, and this mucus protect the internal lining of the small intestine. Mucosa contains tall columnar epithelial cells, as in the duodenum and the previous parts of the digestive tract, and extends into the circular folds and finger-like projections villi. The circular folds. These folds increases the surface area. They are also known as valves of Kerckring. And the villi are also present on the surface villi, and on the villi you can see micro villi also. Villi is present in the circular folds, and they are 0.5 to 1 millimeter in length. They are finger-like projections. And the longitudinal section of the villi. This contain arterioles and venules. The amino acids and monosaccharides are absorbed into the venules, and the digestive products of lipids are absorbed into the central lacteal. So this villi is located in the circular folds and measuring 0.5 to 1 millimeter in length. They are finger-like. These increase the surface area 10 times, and the capillary buds in the villi increase the absorptive power further. Then microvilli are present on the villi. These microvilli are present on the villi. They are hair-like extensions about 1 micrometer in length, extending into the intestinal lumen. These tiny projections are known as microvilli. They are approximately 200 million in number. Microscopically, they appear as a mass of bristles and are therefore termed the brush border. They increase the surface area available for nutrient absorption by another 20 times. So already increased by 10 times by the villi. Now again 20 times, and 3 times increased by the folds. The, and fixed to the surface of this microvilli, there are a number of enzymes that finish chemical digestion. Ileum. Ileum is the longest part of the small intestine. The longest part of the small intestine, highly coiled, making up 3/5 of its total length. It is thicker and more vascular than jejunum. And the circular folds are less dense and more separated. These folds are less dense and the width of these folds are higher in ileum. At the distal end, the ileum is separated from the large intestine by the ileocecal valve. Ileum opening into the large intestine, that is the cecum, this valve. This separates the ileum from the cecum. Yes, this is a sphincter formed by the circular muscle layers of the ileum and cecum and controlled by nerves and hormones. The ileocecal valve prevents a reflux of the bacteria rich content from the large intestine into the small intestine. The ileum is rich in immune tissues, that is lymphoid follicles. A characteristic feature is Peyer's patches found lying in its mucosa, which are an important part of gut-associated lymphoid tissue. One Peyer's patch is around 2 to 5 centimeters long and consists of around 300 aggregated lymphoid follicles. These are concentrated in the distal ileum and serve to keep the bacteria from entering the bloodstream. Peyer's patches are more prominent in young people and become less distinct with age. This reflects the age-related reduction in activity of gut's immune system. The layers of the small intestine. As in the previous parts of this in the gastrointestinal tract, the small intestine also contain the layers like serosa. Serosa is the outermost layer, this layer, and consists of mesothelium and epithelium, which encircles the jejunum and ileum and the anterior surface of the duodenum. The posterior surface of the duodenum is retroperitoneal. That is, it stays behind the peritoneal membrane. The retroperitoneal is the anatomical space in the abdominal cavity behind the peritoneal membrane. Organs are retroperitoneal if they have peritoneum on their anterior side only. There is no peritoneum on the posterior side. Posterior side, it is the abdominal wall. So this retroperitoneal space is between the abdominal wall and the peritoneal lining, and the organs present in this area is called retroperitoneal. The anterior surface of the duodenum is retroperitoneal. So there is no serosa. The epithelial cells in the small intestine have a rapid renewal rate with cells lasting for 3 to 5 days. The movement of the small intestine causes a lot of rubbing in between them and also to the walls of the abdominal cavity, and this can damage the cells. So the cells will be replaced in every 3 to 5 days. Then the layer, muscularis layer, as in the case of esophagus, there is a muscular layer. It consists of two smooth muscular layers, a thinner outer longitudinal layer. This is the longitudinal outer layer, and an inner thicker circular muscular layer. Then nerves lie in between these two layers. Outer longitudinal layer and the circular layer, the nerves are lying in between these two layers. That is the mesentery plexus. This is exactly same as in the case of esophagus. And these nerves allow the muscle layers to work together to propagate food in a proximal to distal direction, only in one direction. Then comes the submucosa. Submucosa consists of a layer of connective tissue that contains the blood vessels, nerves, and lymphatics. Blood vessels, nerves, and lymphatics. Mucosa. The mucosa is the innermost layer and is designed for maximal absorption by being covered with villi protruding into the intestinal cavity. This increases surface area. The crypt layers of the small bowel, that is the area of continual cell renewal and proliferation. The script area. This the cells. This here the cells are rapidly produced for renewal of this layer. Cells move from the crypts to the villi. From the crypts, the cells will move to the villi and change into either enterocytes, goblet cells, Paneth cells, or endocrine cells. You may remember the structure of stomach glands. So all the cells are produced from here and replaced. Mesentery is a double fold of the peritoneum that not only anchors the small intestine to the back of the abdominal wall, but also contains the blood vessels, nerves, and lymphatic vessels that supply the small intestine. So, as in the case of esophagus and stomach, here also a mesentery is connecting the small intestine to the abdominal wall. So, this also connects, also supply blood vessels, nerves, and lymphatic vessels through this membrane. The wall of the small intestine houses numerous microscopic glands. Secretions from Brunner's gland, these glands. In the submucosa of the duodenum, functions principally to protect the intestinal walls from gastric juices, that is, they secrete mucus. Lieberkühn glands, crypts of Lieberkühn. These glands, occupying the mucous membrane, secretes digestive enzymes, provide outlet pores to Brunner's gland. Yes, this is a crypts of Lieberkühn. So from the Brunner's gland also the secretion is going out through this Lieberkühn crypts. Produce cells that replace surface membrane cells shed from the typology. That is what I said before. Peristaltic valves move materials undergoing digestion through the small intestine, while churning movements called arrhythmic segmentation mechanically break up these materials. Mix them thoroughly with the digestive enzymes from the pancreas, liver, and intestinal wall and bring them in contact with the absorbing surface. Passage of food through the small intestine normally takes 3 to 6 hours. That is why we are told our food eating should be at a gap of 3 to 6 hours. Inflammation, deformity, and functional obstruction may impede passage. This can prolong the time needed for passage. Blood supply and lymphatic supply. The arterial blood supply for the small intestine comes from the celiac trunk and the superior mesenteric artery. The superior pancreatico-duodenal artery, which comes from the superior mesenteric artery, supply blood to the duodenum. Superior mesenteric artery. That is branched into inferior pancreatico-duodenal artery, anterior inferior pancreatic duodenal artery, posterior inferior pancreatic duodenal artery, then anterior superior pancreatic duodenal artery, posterior superior pancreatic duodenal artery, gastro-duodenal artery. This comes from the gastro-duodenal artery and that originates from the common hepatic artery. The jejunum and ileum receives blood supply from a rich network of arteries that travel through the mesentery and originated from the superior mesenteric artery. The multitude of arterial branches that split from this superior mesenteric artery is known as arterial arcade. So, lot of branches are originating from the superior mesenteric artery. This is known as arterial arcade. They give rise to the vasa recta that gives the blood to the jejunum and ileum. The vasa recta is supplying blood to the ileum and jejunum. The venous blood mimics that of the arterial supply, which coalesces into the superior mesenteric vein, which then joins with the splenic vein to form the portal vein. So the blood is collected back by the venules, which mimics the arteries. Then they join with the mesenteric vein, and the mesenteric vein join with the splenic vein and form the portal vein. Lymphatic drainage starts at the mucosa of the small intestine into nodes next to the small intestine in the mesentery. So the nodes are there in the mesentery. So the lymph is drained into the nodes. Then from the nodes near the arterial arcade, then to nodes near the superior mesenteric artery and superior mesenteric vein. Lymph then flows into the thoracic ducts and then empties into the venous system, left internal jugular and subclavian veins. So the lymph is finally drained into the left internal jugular and subclavian veins. The lymphatic drainage of the small intestine is a major transport system for absorbed lipids and the immune defense system and the spread of cancer cells coming from the small intestine. Innervations. Nerves lead to the small intestine from two divisions of the autonomic nervous system, that is both parasympathetic and sympathetic. Parasympathetic nerves initiate muscular contractions that moves food along the tract, that is peristalsis. Sympathetic nerves suppress intestinal movements. The parasympathetic fibers originate from the vagus nerve and control secretions and motility. The sympathetic fiber comes from the three sets of splanchnic nerve ganglion cells that are located around the superior mesenteric artery. Motor impulses from these nerves control blood vessels along with gut secretions and motility. Painful stimuli from the small intestine travel through the sympathetic fibers as well. Thank you.